Hello once again, I'm Extra Life. When last we spoke, I was finishing up this engineering prototype of the Super 16 sequencer, and today I would like to make it look a little bit more professional, and finally finish up the software for it to transform this module into the sequencing powerhouse it was always meant to be. When I built the first Super 16 prototype with my homemade hand-etched board, I gave it a homemade hand-lettered faceplate to match the look of my rustic DIY modular synth. But for the new module, I think I'd like it to look a little bit more like something you might want to have in your own modular synth. So we are going to manufacture a faceplate from a sheet of aluminum and label it using the toner transfer process. Anytime you're doing toner transfer, you're probably going to start in the computer with your artwork. Here is my version in Adobe Illustrator. I've got the PCB silkscreen overlaid so that I can position my components. And I've got some previews to see how it looks, and then I put on some drill marks and the labels for text in black and white. And then we're ready to print, and you want to print it mirrored. So in Illustrator, you look under Output and you select Emulsion Down. And that flips the image, as you can see in the preview, from left to right. Now we're ready to print, and this time I'm trying to print it out on wax-coated sticker backing paper. You can see I've given myself 4 tries at success here. And the idea with the sticker backing paper is that it kind of functions as a toner release. So after cutting it out and taping it to the metal panel, I run it through a laminator. You can also use a regular clothing iron set to a medium-high temperature. When you're running it through a laminator, it's important to send it through a bunch of times and make sure that the entire surface kind of gets even exposure to both pressure and heat. After about 10 passes, I peeled back the paper and took a look at the transfer, and I wasn't super psyched with the results. You can see there's a lot of toner still on the paper. And people online swear by this method, and in theory it saves you a lot of work because you don't have to soak the paper and peel it off fiber by fiber, but I have yet to find a recipe for this that works as well as dissolving the paper. One of the papers that works the best for these kind of transfers is glossy magazine paper, and it works really well because it dissolves in water really easily. Unfortunately, printers often don't like it, so the easiest way to use it with a laser printer is to cut out a piece the size of your panel and then tape it to a carrier paper, which is usually just, regular letter-sized printer paper. Then you can feed it into your printer, either through the document feeder or the sheet feeder, and it typically will work okay with the spindles and the motors and just print right on top of whatever medium you've taped onto it. Sorry for this overexposed shot, but it did work okay. And then you just remove it from the carrier backing paper, and you're ready to go on as normal. First, you cut it down to size so that you can tape it successfully to your panel, and then you run the panel and the transfer through the laminator a bunch of times at an angle, sideways, upside down, every which way. Then, of course, you have to soak it so that you can dissolve the backing paper. And magazine paper, of course, dissolves really quickly, and it peels up quite nicely. Yet another alternative would be to use specially designed toner transfer paper, which has a release chemical additive on the back, supposedly that makes it adhere less well. But I've had pretty good luck with magazine paper. You can see the comparison between the two. On the left is the magazine paper, on the right is the wax sticker backing paper, where the toner just failed to transfer. And on the left side, unfortunately, we have the problem of the paper sticking to the toner. But you can see with a little bit of soapy water, you can rub it off. And I actually wasn't super satisfied with the results of this transfer. It's a lot better than the wax-coated paper transfer, but I went ahead and did it again anyway. And I made some adjustments to the artwork to make some of the thin lines a little bit thicker, to make sure there weren't these tiny little islands of toner that were really hard to transfer in the laminator. And actually, making sure that your artwork is toner transfer ready is one of the big steps that most of the tutorials don't cover. But it really just entails making sure that you don't have too much fine detail in any one spot, or if you do, that it's surrounded by enough toner that the metal can stick to a big enough chunk of it to hold the whole thing down. So for example, the small drill marks that I made before with just plus signs, I converted those into circles with negative space for the intersection of the two lines. And third time's the charm, I finally came up with a transfer I was satisfied with, and with a little bit of soapy water and some rubbing alcohol, I got all of the adhered paper fiber off and was left with a nice, dark, high-contrast toner transfer that has all the fine detail that I wanted and nothing terribly wrong with it. Of course, it's not a quick process, you can't use it for mass production, but if you have a little bit of patience, you can get excellent results. Of course, the result is a little bit fragile, so it's best to protect it with some clear coat before you drill. As you can see by all of the new text and labels on this fancy new faceplate, I have added a ton of features to this sequencer since last you saw it, and so I'm going to try and go through them relatively quickly and give you an overview of everything that's changed. First and foremost, I have spent a bunch of time over the past couple weeks scratching my head about the subject of memory management, and the result of this labor is that we are now able to save and load sequences to the patch memory, which is the flash memory chip on the back of this CPU circuit board. So, if we want to load up a sequence from memory, we can just pick a patch number, and boom, it's instantly loaded onto our sequence, and all of the recorded values are loaded along with it. Let's hear how it sounds. If we want to make some changes, we can record them in. We can save them to a new patch if we like. If we want to go back to the old version, we simply load it up. And of course, the sequencer picks up in real time, so wherever we are in the currently playing sequence, it picks up to that same point in the new one. Another big change I've made is to enable the auxiliary control voltage output, which is controlled by this knob over here. And you can sort of think of this like velocity. It's an additional analog voltage that goes out for each step. So if we like, we can hook it up to, for example, filter frequency. Or let's say we want to hook it up to pulse width for the square wave. A lot of the other changes I've made have to do with making it easier to program new sequences. So for example, we can do motion recording with the record button and any of the knobs, as we demonstrated last time. So if we have a blank sequence, we can record in new chromatic steps. That might not be exactly what we want, so I've added some new options for scale selection. You can see we start out in chromatic, we have major and minor, and a selection of other scales that we can use to program things into. The scale selection affects the motion recording as well as the note selection parameter itself. So as you can see, rather than going from 0 to 12, we skip around only on the scale degrees that are in the scale that we've chosen. So let's choose a major scale and program a new sequence. We can also adjust the scale quantization in real time by letting the sequence play and then choosing a scale as it moves. Settings like the scale quantization are actually saved with the sequence itself, so if you load it up later and want to make changes, it'll be easy to just press record and play them in. Another major change I've made is to extend the sequencer capability by having it be able to play more than 16 steps in a sequence. So to access this parameter, we press Shift and Steps, and then adjust the number of steps. So for 2 bars, we might want a 32-step sequence. We can also adjust in increments of 8 by continuing to hold Shift while we adjust the steps parameter. Now we're hearing a 32-step sequence, but there's nothing on the second bar. To access the second bar, we press Shift and then the step that corresponds to the bar we want to access. And then we can record in new data just like with the first bar. We can also copy and paste bars by pressing Shift and then 2 bars in sequence. So if we want to copy bar 1 to bar 3, press Shift 1, hold it, and then press 3. We can likewise copy bar 2 to bar 4 by the same method. Now if we change the length of our sequence, to 64 steps, we can edit the third bar separately and produce variable sequences. To play a sequence over from the beginning, we can press Shift and Play, which will reset the playhead position to step 1. As you can tell by the labels I've added down here, there's also a new setting for swing timing. So if we press play and adjust it, we can hear the swing come in and out. We can also dial in some negative swing for some really weird timings. And of course we can adjust the sequence up or down by a set number of semitones to write songs in different key signatures without having to recalibrate our oscillators for every song. Hopefully that demo gives you a good idea of all the new features that I've packed into the sequencer's diminutive 22 horizontal pitch. With the patch memory, the adjustable transposition and scale selection and swing timing, it now has all the features that you would really need from a capable digital sequencer. But there's one more thing I'd like to show you that should make it a little bit more fun to perform with this instrument, and for that I think I'd like a little bit of accompaniment. As before, we can sync the sequencer to an external clock. In this case, we're using the electron model samples to send out a MIDI signal, and then getting just a regular clock signal from our MIDI to CV converter. And of course, we can adjust the tempo on one and change it with the other. But what I really wanted to show you are the new effect or mutation modes that I've added to the sequencer in the meantime. Last time we looked at beat repeat or step repeat, and we can still access that by pressing that and holding mutate, and then adjusting the data or the number of steps that we repeat. You can select a performance effect to go with each patch by pressing Shift and then mutate. And now you see the list of effects that we've got. Up next we have repeat and then reverse. After reverse we have octave shift, which is a lot of fun. So as you can see, these effects are designed to help you use this sequencer as a performance instrument as well. Up next we have a randomization effect, which changes the pitch for each step within a certain random amount, conforms it to the scale, and generates new improvisational melodies and sequences for you. And the amount of randomization is controlled with the dial. Up next we have a stutter effect, which adds steps in between wherever you have rests in the sequence, and you can adjust the length of those steps. And finally we have a roll effect, which lets you add subdivisions of each step. Well, there you have it. Hopefully you can now see the progress that I've made on this module in the intervening time, and hopefully that demo got you as excited as I am to play with it some more. As I head into the final phase of development with this module, I'm going to be soliciting some feedback on the interface and design, as well as looking at ways to maybe make it a bit easier to build and assemble, maybe switching to some surface mount parts instead of using all of this through-hole technology. Next time, I hope to be showing you the final hardware version of the sequencer, incorporating all of the changes and revisions and bug fixes that I've been keeping track of, as well as making an announcement about how you'll be able to build or buy your very own Super 16 Eurorack modular sequencer. Thank you as always for watching. I hope you enjoyed that, and I will see you next time.